So I am going to continue our discussion from the next question, that is graph question. So we have four questions remain which we, we have left for the discussion. These are the questions we haven't attempted yet. The two questions we have attempted of BD and DP. The third one is of the graph. So let's read the problem statement. So you have n boxes labeled from 0 to n minus 1. You are given, so the question name is 1298 maximum candies you can get from the boxes. You have n boxes labeled from 0 to n minus 1. You are given 4 arrays, status, candies, key, and contained boxes. So basically, you have n boxes, and the boxes are labeled from 0 to n minus 1. You are given 4 arrays, and additionally, you have given 4 arrays. The names of the arrays are as follows: status, candies, keys, contained boxes. Where status I is 1 if the ith box is open, and 0 if the ith box is closed. So a status of I represents that ith box is opened or closed. So candies I is the number of candies in the ith box. So candies I represents that how many number of candies are present in the ith box, and key I is the list of labels of the boxes you can open after opening the ith box. Keys I represents the labels of the boxes which you can open after opening the box I. So contained boxes I is a list of boxes you found inside the ith box. So contained boxes I is a list of boxes which is found inside the ith box, which is present inside the ith box. So you are given an integer array, initial boxes, that contains the label of the boxes you initially have. You can take all the candies in any open box, and you can use the keys in it to open new boxes, and you can use the boxes you find in it. Okay. So return the maximum number of candies you can get the following above rules. So the rules are as follows. Basically, we have n boxes. Boxes are numbered from 0 to n minus 1, and additionally, we have given 4 arrays. The status I represent that ith box is opened or closed. Candies I represents that how many number of candies are present in the ith box. And contained boxes, the keys of I is a list of labels of the boxes that you can open after opening the ith box. So basically, key of I represents the represents the labels of the boxes which you can open after opening the ith box. Okay, so that's it. We have contained boxes I is a list of the boxes you found inside the ith box. So contained boxes I is a list of boxes you can find inside the ith box. So the question is like that. Basically, you have box. In each box there is some box, and inside that box there is some box. So the boxes are arranged in this manner. So you have some initial number of boxes. So basically, in the question it is given that uh, you are given an initial array, initial boxes that contains the labels of the boxes you initially have, and you can take all the candies in any open box, and you can use the keys in it open new boxes, and you also can use the boxes you find in it. So देखिए, so you have given some number of boxes initially, and in those boxes there will be some box which is opened, and you can open that box because some is open. So you can use the keys present in that box, and also if and also you will reach to some boxes after opening that box, because inside that box there is some boxes, so you can reach that boxes. Okay, so that's it. You can reach at that boxes, and after reaching that boxes, either you can open it or not open it. If you have keys to that box, you can open it. If there is no key, if it is already opened without key, so you can open it. So like that we can start opening the boxes and using the keys, and again opening the boxes, again using the keys, and collecting the candies. So like that we will open the first box and we will find some keys. After that, what we will do, we will open some boxes for which the keys is present. We have some keys for that boxes, and we will open that. In this manner we will open the box, getting the key, open the box, getting the key, and finally got some number of candies. So in the question it is telling that return the maximum number of candies you can get following the rules above. So how much is the maximum number of candies you can get after you can get the following the above rules? So how much candy, maximum number of candies you can get following the above rules? So these are the rules we have. So we have to find the number of maximum number of candies we can get. So how can we go for it? So let's see the constant. So n is equal to 1000. So basically we have 1000 boxes. We have 1000 boxes. How we can go for it? So how we can start our problem? So initially we have given some number of boxes, initial boxes that contains the label of the boxes you initially have. So we have initially some boxes. In those boxes, some boxes will be opened. So we will start our. अरे माधव जो तुम जाओ तो पहले. So let's talk how can we proceed in this question. So we have given some boxes initially we have. So let's store those boxes in a set. So I am storing those boxes in the set. So initially I have some boxes. I am storing those boxes in a set. Now in this set there will be some boxes. There will be some boxes which is opened initially. So I will put those boxes. I will put the indices of those boxes in a queue, let's say. So in a queue we have some number of indices, ind1, ind2 and so on, ind3. These are the indices of boxes. We have keys of those boxes. Now I will pick one of the boxes, and I will open that. So what I am going to get? I will get some keys and some box and some candy. So these are the things we can get. So I will put those. So from those boxes, so once I open the boxes having indices I and D1, so I will get some boxes and I will get three things. I will get some box, some candy and some key. So in those boxes, I will have some keys of those boxes. So what I will simply do, I will do simply one thing. I will first put all the keys, mark all the keys that I have gotten the key of those boxes. So I will mark the boxes whose keys I got. And then after what I will do, I will iterate over one of the boxes one by one. One of the boxes. So now I will collect the keys, and what I will do, I will simply put the boxes in the box queue. No. So let's do one thing. I have some initial number of boxes. I have some collection of boxes initially I have. So in those boxes, some boxes will be opened. So I will remove those boxes from this list and push the indices of these boxes in the queue. I will simply do this, and after that, what I will do? I will start getting opening boxes from the queue. So I will pick the top boxes from the queue and I will open it. Three things I am going to get: some boxes, some keys, and some candy. So simply I will collect the candy. So I will collect the candy in the total candy. I will increase the count of candies, the candy variable. Okay. Now I have two things: some boxes and some keys. So using these keys, some boxes I have originally present that I can open. So what I will do? I will simply check that I will iterate over key, and I will check that is there any boxes which is present. Actually, let's do one thing. What we should do, to collect all the boxes first and put them in the set of boxes. Let's say I have a set in which I will collect all the boxes which I currently have, and then what I will do, I will push all the queue in a list in which the keys are placed. So there will be some one queue in which I am putting all the keys I have. And what I will do next, I will start picking the keys from the key queue, storing the key, and I will pick the front key present in the queue, and then I will check that the box corresponding to this key is present in the box set or not. If present, then insert that box number in the original queue. Otherwise, push it in the back of the queue. Then in this manner, do iterate over this key queue. So basically, we have three things. We have a set in which I will insert the box number which I currently have. Then there will be a queue in which I will push the keys, indices of keys which I currently have. The first thing I have is set, and the second thing I have is queue, in which I will store the indices of the key. So this is the first thing, this is the second thing, and the third thing I will have a queue in which I will store that the box number whose key I have. So I can open the box indices of the boxes which are present in this case. So in this way we will do our things. So do one thing, let's say start one thing. So let's code the thing. So what I will do, I have simply a vector initial boxes. It will include all the boxes number which I currently have. Okay, these are the boxes number I have currently have. What I can do, so number of boxes I have is n, numbered from 0 to n minus 1. So we need three things, that which boxes I currently have. So let's say I have a vector of int box. So I have a vector of int box and its size is n and comma 0. Okay, this is the thing we have currently. Now what I will do, I will have a queue. I will have a queue in which the indices of boxes will be present, which I currently have. Indices of boxes which I currently have. The boxes, indices of the boxes whose key I currently have, and the boxes also currently I have. So what I can do? So I can iterate over the initial boxes. Okay. I will iterate over the initial boxes. Now I have an integer that is the box number I have. So first check it, status of the box. If a status of the box is open, that means I can open that box. So let's make a queue of int. So this is going to store the indices of the boxes which is opened. So if a status of it is going to be 1, that means the box is opened. The ith box is open. So if the ith box is open, so I will simply push it in the queue. Okay, and also I will do one more thing, that this box is present. I have this box. So box of it is equal to 1. That means this box is currently I have. Now what I can do next, and if this is not the condition, then just mark that I currently have this box it. So box of it is going to be 1. Okay, this is the case we have. And after that what I can do, so I have a box in which I will mark that which number of box I currently have. And let's say we have another thing. Let's say I have another thing, queue of int key. So I have a queue whose name is key. It is going to store the indices of the boxes whose key I currently have. Okay, and I will have a final variable int candy. So I have another variable int candy. So after calculating the whole thing, candy variable is going to store the number of candy I can get. So from here what I can do, so let's write a line, file is not q dot empty, जब तक कि क्यू खाली ना हो जाए। कौन सा की इसमें बॉक्स रखे हुए, so let's open the front one, so int x equal to, so the can box present at the front, let's open it because the key already I have for this box, so x barabar q dot front, so let's pop from the this x, I will pop from the q. Now if I am going to open it, I will get some candy, some boxes and some keys. So I have a keys and I have a contained boxes. So I will iterate over the contained boxes and I will iterate over the keys. So first iterate over the contained boxes. Okay. First iterate over the contained boxes. So contained boxes. So, contained boxes. So I have a for int ch, so contained boxes, so I am iterating over the contained boxes of x. So this is going to be give me one by one the boxes which is contained in the box number x. So what I will do, I will simply mark this ch box that I am owning this box, that if I have key I will open it. So box of ch is equal to 1. So after doing these things, what I will do next, I will iterate over the keys. So I will iterate over the keys. So let's say int ch keys. So I have a keys vector keys, the keys vector. So keys of x. So I will have these keys. So I will push these keys in the queue, and the indices of the, so there is a key name of, there is a name, we have a queue whose name is ky. So I will push the ch in ky. So ky queue is going to store the indices of all the keys which I currently have. So now I have all the boxes currently I have and all the keys which I currently have. Now I can pick the boxes from these collection of boxes if there is a key for the corresponding box is present in the ky queue. So what I will do, while let's say I have a int sz is equal to nothing but ky dot size. So this much is number of element which I currently have. Now what I can do, I will have a for loop for int I equal to 0, I less than sz and I plus plus. So this loop is going to run sz times. So I will have a int ch, let's say int k is nothing but the key currently I have. So, and what I will do, q dot pop, not q, it's not q, it's ky, it's ky. So I have a key whose id is k, so it can open the box whose id is k. So let's check that box present currently I have that box or not. So if box of ky is equal to 1, that means this box, I currently have this box. So what I can do, I can simply open that box, and opening that box means simply push the ID of that box in the queue. So let's push in queue, push k, it's k. Okay, and if this is not the case, then simply do one thing, in ky again push this k. Okay, so after doing all these things, and these are the things we have. Now I currently opened the box number x, so it will have some number of candies. So our total count of candy will get increased by candies of x. So I will have to update the that value. So candy plus equal to candies of x, candies, candies, candies of x. Okay. So after doing all these things, our candy is going to will should store the maximum number of candy we will have. So let's run it. It's actually working or not. So I am currently out of network. रिकर्शन में जब बैक पैक लगा रिकर्शन लगाते हैं. So let's run it. It works or not. 7. So you will be initially given box 0. You will find 7 candies in it. In boxes 1 and 2. Box 1 is closed and you do not have a key for it. So you will open box 2. You will find 4 candies and the key to box 1 and box 2. So second box is opened, but we have no key. Acha, we have a mistake here that let's say you got some boxes. In that boxes, there will be some boxes whose keys are present. There will be some boxes which are opened. So what we can do, while getting the boxes, while iterating over the contained boxes, check that if if the box is already if the box is already opened, that means there will be some box which is already opened. So just push the index of that boxes in the queue now. So let's check it here. If box of if status of status of ch is equal to 1, that means I have a box which is open now. It's open now. What we can do? We can simply push ch that this box I currently have, and I will continue, and I will not push the I am iterating over the our key here. So just and I will not mark the box number ch is equal to 1, because if I will mark, it will again get pushed in the queue, and which I don't want, because once it got pushed, it should not run again. Na? So that's why I am modifying the code while collecting the box inside some boxes. So these things. So after this, I think now it should work. Okay, it's working. So let's check on the all test cases. It was not that much hard, I think. And with the idea in just one attempt, it's not that much hard. Just tagged hard. Oh, really? LE. Recently. 1000 कैंडी एन 1000 हो सकता है. We should do. We can little optimize it by doing one more thing. That initially I have some size, I have some in our queue. There is some boxes and some keys. So these boxes are open now. So why don't we run all the boxes first, and then I will push the keys or whatever we have. matlab, Then I will collect the boxes whose keys are present. So I can do one more thing here. Let's say I have a int sz1 equal to 2 dot size. So what I can do, I can run a loop for int j equal to 0, j less than sz1 and j plus plus. I will run a loop. So just run a loop from here. P dot push. Collect this much. Okay. How can we optimize the box whose keys are present? Now, we can do one more thing. While collecting the keys, take that do like this, like this. It will optimize. I was thinking that time I will open a box candy plus equal to candies of x. Which parts I have to write inside the loop. Okay, I think this much going to work. It will still not give very well. So it is giving runtime error. Runtime error. So overflow. It's overflow. If some boxes is pushed in the queue, I don't want to push that boxes again in the queue. So is that situation rising or not? Okay, so talking st, make it a set whose name is st. Okay, push the box number I have visited. S dot insert dot insert id. While pushing the box, check one thing. Okay, let's check one more thing. Not not st dot count th. Th is already not pushed in the queue, then only push it. Otherwise, not push it. Maybe the case that in more than one boxes there is box. Same box is present. If not st dot count a. Okay. After pushing it, t dot start a. Okay. I think has been resolved. Okay, let's check. Okay, it's accepted. So it was the case that in some, there may be case that some boxes are present in more than one boxes. So I haven't write the code for that situation. That's why it was failing. For that, I simply have to mark that which boxes I have opened. So I am not going to open it again. For that, I am inserting the box number of boxes, index of the boxes which I have pushed in the original queue in a set. And while pushing some element in the queue, I am just checking that that box number already have visited or not. If not visited, then push it. That's it. We have. So we have done with this question. It was not that much tough. So we can move to our next question. We can move towards our next question. So this is the question I have. So we have three more questions. The question I have: you are given nums an array of positive integer of size 2 into n, and you must perform an operation on this array. The ith operation, you will choose two elements x and y. So you are given nums an array of positive integer of size 2 into n. You must perform an operation on this array. In the ith operation, you will choose two elements x and y and receive a score of I into GCD of x comma y. Remove x and y from nums. Okay. So I have an array whose name is nums, in which there are two n integer present. Even number of elements are present in the array. You must perform an operation. You can perform an operation on this array. In the ith operation, you will choose two elements x and y, receive a score of I into GCD of xy, and remove those elements x and y from the nums. This is the basically each step we can pick two elements from the nums array and how much score you are going to get. If you are picking that element in the ith operation, the score you are going to receive at this in the ith operation is nothing but GCD of the picked number times I. Your score is going to increase by this much of amount I into GCD of x comma y in the ith operation. So and after doing this operation, you will just remove that x and y from the nums. So return the maximum score you can receive after performing an operation. So our task is to that how can we achieve the maximum score, how can we achieve. So this is the task I have. Let's find one more thing. That nums of I is going to be less than equal to 10 to the power 6. So all the integers present in our nums array is going to be less than equal to 10 to the power 6. So this is the key point we have. So what next? Greatest common divisor. We have two number x and y. We have numbers. We have numbers x and y will be belong in the range 1 to 1e6. So what you can comment over the GCD of this x comma y. The first order of the nums array doesn't matter. So we will first sort the nums array because order doesn't matter. Sort the nums array. Also, let's see the constant we have. N is equal to acha. N is less than equal to 7. The n is very less. Number of element in this is going to be just 14. So we can do one more thing. We can use bit masking. So we can just use bit masking to do it. We can bit masking. So we have a number of 14 elements in the nums array. So 3 power 14 is going to be equal to almost 3 power 14 is going to be less than 3 into 10 to the power 4. No, it's less than 4 into 10 to the power 4. So so we can use mask now. What I will do? Let's say I have a function f, and initially I have nums array. Okay, nums array, and some number of elements I already have used. Okay, this much of information I have. There is many ways to pick elements from the remained nums array. There is some element which is already used, and there is some element which is not used. Basically, we want to pick elements from those unused numbers. Basically, we can run a loop of n square. N is going to be 14. So 14 into 14 n square 28. We can run a loop of 228. What I will do? I will for all pairs of I comma j which is not used, the element present at ith index and the jth index is not marked in the mask, then I will simply make a pair of I comma j, and our score is going to increase. In that case is nothing but GCD of nums of I comma nums of j. We can calculate this using the function in log n. So we'll go in log n. So for each pair of I comma j, we'll have a score which is equal to nums of I comma nums of j. This is going to be a score, and further I will make some pair now. For that I will simply call the function f, give him the nums, and give him the updated mask 1 in which the I and jth index will get visited. So in those all ways of picking I comma j, there will be some way which is going to give you the maximum score. So you are going to return that score. So it's very and we will use DP with bit masking from there. So it's a very simple problem. It's not that much of touch. So we can simply go for this problem. Let's write the code of this problem. We will write the code of this problem. So just simply we have return f of nums comma, but we have a mask in which no elements are visited now. What I will do? This f is going to return me an integer value, that is maximum score which I can achieve by picking the elements one by one. Achha. What is the number of operation this time I have? So I haven't operated any operation. Basically, I am currently at the first operation. Okay, I am currently at the first operation. So let's make it one. So int, so you are currently at the operation I, and what is your vector of int nums? It is your nums array, and we have a int mask. So these are the things we have. Int mask. Okay. What I can do from here? What we can do from here? We can simply do one thing from here. That I will run a loop. So let's run a loop for int. So let's make it int, because I will run a loop over I and j. So int I equal to 0, I less than nums dot size, and do one more thing, I plus plus, and again run a loop inside this loop for int j equal to I plus 1, j less than nums dot size, and j plus plus. So these are the things we are going to do. So if now I can first I will check that can I make the pair with I comma j, element present at index I and j. So for checking that, I simply have to do one more thing, nothing but mask and one left shift I. So if I am going to end with the, it should be 0. I am ending one left shift I with mask, and if I bit is not set in mask, then it is going to give me 0. So if it is 0, then I can use I. In a similar manner, How I will check that can I use J or not? Simply copy this line and paste it here. So paste it and write it here J. So if is equal to 0, that means I can use. That simply means I can make a pair of I comma j. So if I am going to make the pair, then how much score I am going to get? Let's say SC is the score I am going to achieve. So it is equal to nothing but GCD of terms of I comma terms of j. This is going to achieve. I am going to achieve. This is the amount of score I am going to achieve. Now what I can do? I can simply do one more thing. The thing is very simple. So I am going to pick it. So let's say I have a score. Score equal to maximum of a score comma SC plus F of I times SC. I and D times. This is the ith operation. I and dth operation I have done. So I will increase the number of operations by just I and D plus 1. Nums is going to be the nums. And mask is nothing but mask 1. So these are the things we have. So after doing this whole thing, I will just record a score. Okay. So let's talk about mask. Let's talk about mask 1. What is this mask 1? Mask 1 is nothing but mask or with one left shift I or one left shift J. Okay. This is going to be the mask. Mask or one left shift I, one left shift. So this is going to be the mask 1. So I will simply go for the mask 1 and check. Once this mask is going to equal to one left shift nums dot size, okay, minus 1. If it is going to equal to this, that means I have used all the element present. So in that case, return 0. Further, how much amount you are going to get? It's 0, na? So the recursion should work. So let's see, is it actually working or not? So let's run it. See, it's working or not. So I think most probably it should work. It's a simple DP problem. Nothing we have to do more than that. So I am आप दो नंबर को ऐड करना कैसे ऐड करें so Marie 1 2 3 okay what I can do now it's giving error. So let's declare the score variable integer score and initialize it with 0. Okay, it's working on the first test cases. Let's for the all 3 4 test. It's working. So now simply I want to memorize it. For memorizing it, I will make a DP table. The size of DP table is going to be but the number of pair is going to be 7. So make it 8 and one left shift 14. Let's write a length set of DP comma minus 1 comma size of DP. So this is the thing I have. So let's do one more thing. DP of IND and mask is equal to 4. So then take it. If if dp of ind mask is equal to not equal to minus 1, that means I have pre-computed these things. So I will calculate further. So just return the value. So dp of ind mask. Just return it. Okay. These are the things we have got to do. So let's see if it works or not. So it's working. So let's submit it. So it's accepted. So let's move to the next question. You are given a string s and an integer k. That was a number theory question. It was not actually number theory, it was DP. So you are given a string s and an integer k. You can choose one of the first k letter of s and append it at the end of the string. Return the lexicographically smallest string you could have after applying the mentioned step any number of moves. So basically, you have given a string s and an integer k. You can choose one of the first k letter of s and append it at the back of the string. So these are the things we can do. So basically, we can pick first k character of the s and push it in the back, and we want to check that return the lexicographically smallest string you have after applying the mentioned step any number of moves. We want to find the lexicographically smallest string and we want to return it. So let's see the constant. So the constant we have given is nothing but it's just 1000 length of a string. So we can write a solution of order of n square. No problem. We can write a solution of order of n square. So initially, push all the characters in the queue. So the idea I am thinking that I will push all the characters in the queue. And what I will do, I will simply the first character push it in the back of the queue. That's actually the smaller one. So we can there is not so clarity with me because I didn't have solved the question like this before. It's easy, but lexicographically smallest means as much as possible make it smaller. That's the target I have. If there is a character, there is a smallest character, A is present in the there. Let's say there is a we can do this problem very simply using try. What we can do? We can insert. So worst case, how many string we can have? How many string we can have? N string we can have. In that n string, we want to find the smaller one. No? That's our target. So we can do this problem just using try without using any more things. So I'm going to implement try for this problem. So what the idea behind this try is nothing but so we have n strings. So we have n strings. So let's see if you will pick some k characters from the string top of the string and push it in the back, then what will happen? So it's given k, value of k is given, no? Given or not? So you have given as s. Okay, okay. So this is the problem because of this k. K will be 1, then it will be very easy. But K is not 1. So after some time it is going to repeat now. After some time it is going to repeat. So if you are, let's talk. Little good thing is that here there is a K value given. That's why the question become little good due to this K value given. So let's stop. If let's say there is, if K will be 1, then what will happen? You will pick the first character and push it at the back, and after pushing it at the back, there will be new string you have created. Again you will pick the first one, top one, and insert it at the back. Again. And finally you will pick the last one and push it at the back. And finally your become string become reversed. So in this case you are going to get around n string, and exactly n string. So if I am going to insert those all n string in a try, so in try we will take order of n time to store that string in the try, and we have such n string. So we will spend n square complexity in inserting all the elements in the try. So we will, and after that we can only find the lexicographically smallest in the try in just order of n. So but here is a problem is that here k is not always 1. K can vary from any range. So let's talk what the value of k can affect. What the value of k can affect. So if you are going to pick first k element, then the starting index of your second string is going to be I 0 plus k, and the starting index of the second string is going to be 0 plus 2k, 0 plus 3k, 0 plus 4k, so on 5k, 6k, 7k, 8k, like this. So there is a concept of pigeonhole theory. So I currently don't remember that theory, but that theory states that something like that if you are going to give an operation at this place, you are going to give an operation at this place where n is the length of a string. Then in that operation, if you are not getting an index from here, you can start a string. That simply means you are not going to get it further. If you are add, you are not going to get. Okay. So if you talk about what will happen, 0, 0 plus k, 0 plus 2k, 0 plus 3k, and a time will came when 0 plus, let's say lk, it is going to exceed the value n. So in that case, what will be your starting index of the, from where your current string will start? If the starting index of current string is 0 plus lk, which is greater than n, it's simply modulo n. It's simply 0 plus lk modulo n. That's it. That's it. So one more thing I have. But how I can bound the value of L? That for how much value of L I will find our string. So this is the situation we have. So this situation can be resolved using pigeonhole theory. Pigeonhole principle. Here pigeonhole principle can give you the proof, I think, that why you can only do this, you can bound the value of L by N. That makes sense. Or something like that. Okay, one more thing. you will talk. That thing is nothing but, let's say you will 0 modulo n is equal to 0. Your string is going to start from 1. So again, what you are going to get? 0 plus k modulo n, and it will have some value x, r1, and then you will do 0 plus 2k modulo n. Okay, and you will get some remainder which is r1, r2, so on. So a time will come when you get the same remainder which you already have achieved. That means from there a cycle will start now. You already have get that remainder previously, and again you will. So the situation is like that. You will start from there, r1 plus k again. So it will go round now. So I will going to add the k value till I am not going to get the same indices which I previously got. So in that way, we can resolve this problem and use the try. So we can use the try and also this concept, and using these two concepts we can simply resolve the problem. So orderly queue. Okay. So let's make a set of int, and let's name it remainder. Okay. What is the value of remainder I already have achieved? Let's run a loop. While 1. Let's run a infinite loop. While 1. Okay. What we can do? We have a value L in x equal to 0 initially. So okay, x is equal to 0. Now what we can do? Just do a very simple thing. Nothing but insert. Let's say I have a try and I am telling that insert this string s, insert in, insert this string s in try. So this try is going to insert the string s, because string s is going to be the string which is starting from index 0 of its own string. Okay, now what the next we have? Okay, so inside this loop I will write a value int val with x equal to x plus k. So update the x is equal to x plus k. So you will simply move to the x index, k index apart. Okay, now if st dot count x, so let's find the modulo of x. So x modulo. So first find the size of st, int n equal to s dot size. Okay. Okay. And find k modulo is equal to n. And k modulo is equal to n. What we can do from here is that check that k modulo is not equal to n, but x modulo is equal to n. Check that is that x value we have already got or not. So in remainder, first push 0, because 0 is the starting index which I already achieved. I don't want to achieve it again. So push it in the remainder dot insert 0. So in the same manner, check if it is not remainder dot count x. If x is not present in the remainder, that simply means insert in, and the string is going to start from index x, and we have the string s. From here the x value is going to be 0. Okay, and after doing this, the set whose name is remainder insert x. Okay, so I am inserting x in this remainder there, remainder, and if Not the case that this x is already present in remainder set. Break break the loop. Okay. And after doing this thing, what we can do? Let's make an empty string answer. Okay. It is empty string. And let's call a function find and give him the answer. It is going to push the lexicographically smallest string in this answer. From there we will simply return this answer. Okay. So our main motto from here is nothing but we want to make a try. Okay. So we want to make a try. So let's make a class for try. So struct try. So let's make a class for the try. And in try, what are the things we have? We have a vector. So let's define a factor in this try whose size is 26. Okay. So what is try? Try is just a tree like things in which there is a node and in that node there is a vector of size 26 whose at all index of that vector we have a pointer of a node of a try. Okay. So vector of try star v. Okay. So we have a flag. Okay. Let's say we have a constructor try. When we make a node, constructor will run and it will resize size it's 26 and at all index push a 0. That is all index of this try is going to hold null value. After that flag is equal to 0. This is going to do the try. So we have the try. Okay. So let's make a root of the try. So let's make a try star root equal to nothing but new try. New try. Okay. So whenever you want to insert the element in the try, simply have to give the root value also. So give him the root. Okay. These are the things I'm going to give. So here also you have to give root. I will have to give root of the try. Then only it is going to push the element in the try. Achha. Okay. Now I will insert the try. How can I insert? So let's implement the insert function for the try. What we can do? Let's make it class. Not class. We do one thing. Let's write a function which is known, whose name is void insert in, and there is a root node of try star root 1, and we have a int k and we have a string s. Okay, and you are to give one more argument, that is your string is start from 0 and you are currently at the character number 0. So let's give him another data 0. What is the character number you are currently at? Okay. So you have a int int. Let's say int int. So what can be the cases? So you are currently at index, let's say int ind1. You are currently at the index ind1. So ind1 is going to be k plus. Basically, what is the integer k? What you can, it is going to start from Okay. Let's string s. So it is starting from string s, and you are currently at ind th character. Your ind1 is going to be nothing but a plus ind. So this is going to be your okay. But I have an integer n equal to dot size and ind1 modulo equal to n. Ind1 modulo equal to n. So this is the character number you are currently at. Okay. So what can be the cases? There can be two cases. Okay. There can be two cases. Either the element is present. So let's have another thing. This try root. There is a vector. So root 1. So let's check root 1 back of s of ind minus character a. If this is going to 0, there can be two cases now. It is equal to null, or else it's not going to null. There will be two cases. It is either going to null or it is not going to null. These are the two cases. S of ind minus a equal to 0. That means there is, so let's make a new node. So let's make a new node for the try. Try star r is equal to new try. Okay. So let's make a new node. Place it at the root 1 of back of s of ind1 plus a is equal to r. Okay, let's push it. So after pushing it, your element present at ind1 index is inserted in the try. So we will insert the further element, insert in all these functions and give him the value present at this x. Control C. This is going to be the root to the next, and your k value is going to be k value, the s is going to be s, ind is going to be ind plus. Let's check it one more thing. If ind is equal to s dot size, if ind is equal to s dot size, that means you are at the ind index. If you are at the ind index, so what you can do? Make the flag at this root 1. There is a variable flag, make it 1 and take from here. Okay. So in this way we can implement our insert function, and in the same manner we want to insert our find function. For finding also you have to give root. Okay. You have to give, we are currently at what node? Okay. And the length of the string dot size. Okay. So these are the things we have. So let's implement the find function. Can we implement the find? So void find. Let's implement the find function. Find function will have first the root star root. Second thing we will have the string string, reference of s answer. Let's make it answer. And the third argument I can have is int ind or int n. So int ind int okay. Uh, okay. So 4 try star r, and we will iterate over this vector root of okay. We will iterate over this vector, and if I am going to find r is not equal to 0, that means we can simply go to that node. So what I can do, say I have a integer int I equal to, okay. So char ch, let's say we have a character, let's push answer dot back a plus I. So this is the what I am going to push in this answer. After doing this, what I can do, r is not equal to 0, okay. I will run a call the same function find and give him the r value, give him the answer, and give him the ind plus 1, and giving him the n. Okay. And after doing this break here, if ind is equal to n, that means break return. So this is how I am going to push the elements in from our try. So as you can see, I am iterating on the vector present at index at root one by one. So I am basically iterating from left to right, basically A to Z. So if I found a character, then R is not going to null, and if R is not going to null, then I will use this character present at this level. So I will push that. It will be a smaller one. Definitely it is going to be a smaller one. In this way, we will insert the lexicographically smallest one automatically. So don't worry from here. Let's see it is running or not. We run it and check it running or not. Automatic. Is this Marich? Okay. So let's control A, control C. Where is the problem? Okay, like this, get like this. A very big 70 line. From here I have to return the, it's not break, it's return. रूट ऑफ वैक नहीं होगा, रूट ऑफ v होगा. It is little error. There also it will be v. There also it will be v. Which we have to use v. Insert zero. Use of undeclared identifier remainder. Remainder, not remainder. Remainder, not remainder. It's remainder. Insert in. What's the problem? Insert in now. Root 0 S00. Root 0 S. Hey, there is another 0. There will be one 0 after S. It's okay. Well, file number 57, comma 0. It's giving A. This was how I am. Hey, yaar. यार ये क्या है? बहुत दिक्कत है यार. So there is some error. I find that error. There is a simple mistake I have done, that here I didn't have incremented the I value. That's why every time it is going to insert the character X, character A in the answer. That's why it was giving error. Now it's working, you can see. Okay, that's working. So you can simply submit it, accept it. Slowly it's wrong answer, it's giving wrong answer. A, triple A. How it can be A, B, C. Triple A, B, C. How it will give triple A, B, C. How it will give triple A, B, C. B, C. A, C, A, B. According to me, the correct answer is A, C, A, C, A, B, because I have implemented the logic for it. Is giving A, triple A, B, C. How it can be possible? Telling that you can choose one of the first key letter. Oh, you can choose one of the first key letter and append it at the back of the string. So the question is little different, which I have implemented. Very little different. Little